In this video, we're going to be looking at the modulus of a complex number. So, the modulus of a complex number, a plus bi, is the distance from the origin. So the modulus of, let's say, a plus bi is written as a line either side. So a line either side means the modulus of a plus bi. And whenever you see the line either side, you know straight away you need to find the modulus. And all that is then is the square root of a squared plus b squared. So if you look at this question here, z is equal to 4 minus 2i. So 4 minus 2i is going to be here on the argand diagram. And what we're actually going to be finding is the distance from the origin. So the length of this red line. So really what we're going to be doing is using Pythagoras' theorem. Because if you can see there, if I made this a triangle, I'd be finding the length of that hypotenuse. So let's find the distance of the red line. So all we need to do is a squared plus b squared. So we're going to have 4 squared plus minus 2 squared. So put that into the calculator. And that would be root 20, which can then be written as 2 root 5. So that is the modulus of 4 minus 2i. Okay, let's have a look at some other ones. So here we have z1 is equal to 12 plus 6i, and z2 is equal to minus 12 plus 5i. And we need to find the modulus of z1, z2, and then z1 plus z2. Okay, so for the first one there, it's z1. So a is 12, so I'm going to have 12 squared plus then 16 squared. So putting it straight into the calculator like that, 12 squared plus 16 squared, and that's just going to be 20. Next one then, so it's z2, so I'm going to have minus 12 squared plus 5 squared, and that's going to get me then 13. Now for the last one, a bit different, so it's z1 plus z2, so don't make the mistake of just doing 20 plus 13, so I actually need to add them first. So z1 is 12 plus 16i, and then that's going to be added then to minus 12 plus 5i. So I'm just going to write that as 12 plus 16i. So now minus 12 plus 5i. So the plus 12 and minus 12, they will cancel out because 12 minus 12 is 0. So now I'm just left with 16i plus 5i. And that will be 21i. So seeing as 12 minus 12 is 0, I'm just going to put it in like this. Now finding the modulus of this, so 0 squared, I know that's going to be 0. Then 21 squared, that's just going to get me 21. Okay, and that is the basics of finding the modulus of a complex number. So now we're going to have a look at 2 more tricky questions. So in this question we're told the complex number z is equal to 1 minus 4i, where I squared is equal to minus 1. Let k be a real number such that the modulus of z plus k is equal to 5. And then find the 2 possible values of k. Okay, so the first thing I'm going to do here is I'm going to replace this z here with 1 minus 4i. So then I have 1 minus 4i plus k is equal to 5. Now, I was told that k is a real number, so then I will have 1 plus k, so I'm just grouping the k and the 1 together, then minus 4i is equal to 5. So for the modulus, it's a squared plus b squared, and in this one my a value will be 1 plus k. So I'll have the square root then of 1 plus k squared plus then minus 4 squared equal then to 5. So now, to get rid of the squared on the left, what I'm going to do is I'm going to square the right hand side. So I'm going to square 5 to make it 25. So then on the left, I'm just going to be left with 1 plus k all squared plus 16 now equal to 25. So bring the 16 across, it'll be minus 16. So then I have 1 plus k all squared is equal to 9. Now I want to get rid of that squared, so I'm going to square root 9. So then I have 1 now plus k is equal to the square root of 9. So that means 1 plus k is equal to plus or minus 3. Don't make the mistake of just writing 3, because I said 2 possible values of k. So I could have 1 plus k is equal to 3, and bring the 1 across, it'll be minus 1, so then k is equal to 2. Or else I could have 1 plus k is equal to minus 3, bring the 1 across, it'll be minus 1, so then k is equal to minus 4. So my 2 possible values of k are 2 and minus 4. Let's have a look at another tricky one like this. So here I have z1 is equal to 8 minus I, and z2 is equal to 7 plus ki. Then we're told the modulus of z1 is equal to the modulus of z2. Okay, so modulus formula is just going to be a squared plus b squared. So for z1, I'm going to have 8 squared plus minus 1 squared, then equal then to the modulus of z2, which will be 7 squared plus k squared. Okay, so 8 squared plus minus 1 squared, that will be the square root of 65. Then on the left, I'm going to have 49 then plus k squared. Now, to get rid of the square root signs, like the question before, I'm going to square both sides. So by squaring both sides, I'm left now with 65 equal to 49 plus k squared. Bring the 49 across, it'll become minus 49. And 65 minus 49 is 16. So that means 16 is equal to k squared. So to get rid of the squared, I'm going to square root 16. And remember now, plus or minus 4 equal k. And they're the two answers, plus 4 or minus 4. Okay, and that's it. So any questions, please leave in the comments. Thank you.